with any new technology, there's always good and bad. And it's about, I think we are becoming very aware of the dangers of this technology, which means that we will be able to mitigate those dangers just in the same way as we have done with other technologies, sometimes not so successfully maybe. But my feeling is that this is got great potential to reveal, to give us a real step change in the way that we do things. So I think that we're aware of the dangers, which is good. There will be unintentional consequences, and we need to be very sensitive to new things as they appear.
Today we're having a conversation with Marcus de Sautoy, a mathematician who's passionate about making numbers fun and accessible for everyone. As the Simonyi Professor for the Public Understanding of Science at the University of Oxford, he's not just a brilliant researcher, he's also a gifted communicator who brings complex concepts to life. Through his popular books, YouTube talks, and public lectures, he invites us to see the beauty and wonder of mathematics in unprecedented places, from the patterns of nature to the rhythms of music. Marcus, great to see you.
It's great to be with you.
I'm excited to chat with you today. We have a lot to talk about in the world of AI, as well mathematics and your books.
Yeah, looking forward to chatting about all of those.
So could you share some of your insights on the current state and capabilities of AI?
Yes, I mean, I think we went through an extraordinary phase change about 8 years ago, when we suddenly saw the impact that machine learning and the amount of data that's available for training has had on AI. I mean, we've been speculating about AI for decades, but we've talked about AI winters for about 4 decades, and I think we suddenly went into an AI heatwave with this kind of revolution. And in some ways, the phase change, what it entailed was, in the past, code was written in a very top-down manner. A human would write instructions which a machine would be able to implement at speed and at depth that would exceed what a human could do, but still somehow the control was under the mind of the human because they were writing those instructions. So the thought of creativity of an AI just sounded bizarre, because anything that was created by the machine was really had its source in the human. But I think that's all changed, because the style of coding is now a bottom-up process where code is written, which is then allowed to change and mutate as it engages with new material, and in particular new data. And because we're in such a data-rich environment, it's really got a universe in which to inhabit and learn and change. And so I think we're seeing something which is emerging, which is genuinely different from what the human originally coded. And that gives rise to exciting and sometimes frightening possibilities. In particular, what I've been interested in this book I wrote, The Creativity Code, is this gives the chance for code to be creative in its own right, because something might emerge out of that learning process which genuinely wasn't put in there by the human who initiated the whole process, and so might surprise the humans that initiated the code and help us to see things in a new way, which I think is part of what creativity is about. So I think this is a super exciting moment, and that's what we're seeing. We're seeing, suddenly AI is on everybody's lips. It's in the newspapers. I think every day I look at the newspaper, there are several articles about the impact of AI. And I think it's about this kind of change that has happened in the last few years, which has changed the way code is written, which has given this possibility of an AI, which is, I think, what we all hoped it might be for decades, but suddenly we're beginning to see the potential of this new technology.
You know, when you talk about this, we'll talk about Go, because I think you give a really good story about Go and the ability for computers to create code and to be creative in that sense. But the question around that as well, I'd love for you to espouse on, is around if the computers are creating code, if there is a level of independent creativity, is that a form of personality of sentient behavior?
Look, potentially, but I certainly don't think so at the moment. I think what this is actually a reflection of our sentient behavior, because what the data that the AI is learning on is all of our human output, whether it be visuals, paintings, or music, or the written word. I mean, if you think about ChatGPT, that's trained on our text that we've given it. And so I think we need to think of this not as a sentient being in its own right, which we can get onto as speculating about whether that might be possible. I think that's way in the future. But I think what we're seeing is a reflection of our own, cumulative sentience. Because in a way, if you take something like ChatGPT, it's being trained on all of our written output. So it's getting some sort of insight into the way humanity writes and the different ways humanity writes, and it learns from that. And then, yes, it can take us into the new. And that's what's interesting is I think many people feel that, are we just going to get pastiche? It can learn style. For example, it might learn the style of how Rembrandt paints. And we saw an extraordinary example quite early on of a painting in the style of Rembrandt created by an AI that had learned on Rembrandt's paintings and his style, and produce something which, when I show this in talks, I get a kind of 50-50 split between a real Rembrandt and the AI Rembrandt, because it's done such a good job of replicating style. But in some sense, that's not creativity. And I think what's really interesting is if you give it data, first of all, can it spot new opportunities within that data? Or can it actually push into something which is genuinely breaking what the data has encoded in it? So I think we are seeing both of those things emerging, which I would call genuine creativity rather than just replicating style and pastiche.
But do you believe that AI has the potential to surpass human intelligence? And if so, what's the timeline? What are you thinking?
Yeah. Okay,
that's our public timelines. Everything's happening so quickly in this space. What are your thoughts?
It is, and I think that's very interesting because we are referring to this like the Industrial Revolution of the Victorian age, but that was quite fast, but it impacted from one generation to the next. So your children would be doing different jobs. This is so fast that it's impacting on our own lives. So we're having to recognize that our jobs may not be there in 10 years' time, and we're going to have to adapt personally, not generationally, to the new impact. I think that your question about when might AI sort of surpass us is actually a false question. And I think it's one of the mistakes we make. We talk about this thing called the singularity quite often, which is a kind of exciting idea of this moment of superiority of the AI. And I think this, the mistake that's being made with this question is to regard intelligence and creativity as a rather one-dimensional thing where, there'll be a moment when suddenly it's more intelligent than us. And I think the recognition is that it's a very multi-dimensional space. And so this means that there'll be directions in this multi-dimensional space in which AI will exceed us. I think we already see that. My pocket calculator is already better at doing long division than I am. So it's already hit the singularity on that score. But there are other realms where, certainly humans are more superior. So I think that we're never ever going to see a moment of singularity. What we'll see is in this highly dimensional space of intelligence is that there'll be directions in which the AI is better than us, some in which we'll be better, some in which our combined efforts will exceed each other. And I think that is the most exciting opportunity. And I see, I think the whole debate is coached a little bit too much in sort of Hollywood terms of, dystopia and machines, Terminator machines, killing off humanity. And I think actually rather than competition, and this is something I try to express in my book, it's about collaboration, that this is a tool. It's not a new species yet. It's more like the invention of a telescope. I often feel like, Galileo picked up a telescope, was able to see deep into the solar system and see things which changed science. But it was the collaboration of Galileo and the telescope. The telescope couldn't change science. It was the interpretation of what it was seeing. And I think we need to regard artificial intelligence in a similar way, that it's a telescope into our digital world, which is so complex and rich that our embodiment as humans means we find it very difficult to see what's going on inside all of these numbers. But AI is very good at spotting these patterns. It will produce them, but I still think the human will be playing a very significant role in interpreting why those patterns are there and understanding what the message is that the AI has identified. So I see that, I think that's a better way to think about this technology as a new tool which is going to allow us to do new things and will create new jobs and will replace other jobs. I mean, think about the camera. When the camera appeared on the scene, I think there was a big fear that suddenly painting was going to go out the window, because you could just very quickly snap an image of the landscape. And so why would you sit for ages painting the landscape? But we've seen that that's not the case. And of course, most people do not use a camera creatively. Most of us take terrible pictures, and only a few know how to use this tool to create pictures that deserve to be in a gallery or a museum. And I think you're seeing the same thing with AI. A lot of people are using ChatGPT or Midjourney or DALL-E to make things and feel creative, and that's great. It's kind of lowered the entry bar to having a go at making images. But most of those images are terrible. It's only a few people who really know how to manipulate this software to create something really magical.
So you mentioned collaboration, but there will be some instances where it won't be collaborative. It will just be replacing people. It will be changing jobs. And you mentioned that briefly in your response. What does that look like in society when some jobs are completely replaced and some jobs? But I also believe that a whole new wave, a whole new crop of jobs will also be created, right? When you take a look at where we are today with e-commerce, right? We didn't have search engine managers. We didn't have PDP developers. We didn't have a lot of the jobs that exist to just support e-commerce infrastructure. That didn't exist, but now they're here today. So but this technology is different, right? This technology is more powerful and more expansive. So what are your views around when we get to a point where there's significant deployment and we start to see displacement of jobs in different areas?
Yes. I certainly think, we have to face the fact that some jobs are going to go. And so, for example, a lot of the mathematicians that I teach the students in Oxford, they would have gone on to become accountants or actuaries, for example. But that's a job which is not going to be there, I don't think. There'll be a few humans involved, but most of that can now be done very smoothly by artificial intelligence. So I think, and that's why, as an educator within university, I think one of the important things that we're missing about education is teaching our students to learn, that they need to be able to retrain themselves. I think we've traditionally felt like, we train our students up at school and at university, we send them out, and then they're a finished product, and then they go and do whatever jobs they do. And traditionally they have been in jobs for life or for many decades. That is going to change, and so I think we need to really take that on board at an earlier level, that rather than teaching our kids code, we need to teach them how to learn code, because that code will be changing all the time. And so the ability to train, to retrain, and to be fleet of foot is going to be one of the most important skills as we go forward, because of the fast-changing employment terrain. But as you say, with all of these revolutions, some things disappear and new things arrive. So I think that is what we've got to recognize. Okay, already we're seeing those people that understand how this code is working are already in a very strong position to help others who don't understand. So the digital and coding literacy is going to be incredibly valuable going forward. Take the creative arts. I think already you see in something like Midjourney that you've got to write a prompt in order to be able to create visuals. But the ability to write good prompts is also going to be a new sort of skill. It's almost like a sort of coding poet to be able to conjure up something which will make the machine do something interesting. So we're going to have a lot of people who will be trained to get the best out of these tools. But I do think we have to recognize that things like, in the book I talk a lot about creativity. So I don't think the top level painters, composers, writers are going to be under threat. What is under threat here is the second tier, are those composers that perhaps didn't make it into the concert hall but are using their skills to write music for television, for adverts, for corporate videos. Unfortunately, because of those are not the primary thing that people are engaging with, they will probably be replaced by a machine that can produce this, and the copyright issues will not be significant for a television company using an AI to create some sort of background to a particular scene with an emotional content to it. That will be something that will basically, I think the human will find themselves drifting away from doing those. I mean, for example, take computer games. Music is incredibly important to a computer game, but everyone plays a computer game in a different way, and they will navigate their environment. If they're playing Zelda, they might spend more time in one place or keep going back and forward or fighting. The ability for an AI to make a bespoke soundtrack for the particular player based on a learning of their particular style of play is an really exciting potential. Whilst if you leave that in the hands of the human, they will have to make chunky little bits which just don't mesh well together. It's just a matter of scale here that means that an AI will be able to make something really bespoke. I think that will also be true in kind of my area of writing books. I find often that I want to write a different book for each different reader because they will have different backgrounds, different experiences. Some may be much more mathematically literate. Some may have no mathematics and be scared of it. And I've got to write one book which has to work on many minds. Imagine sort of collaborating with an artificial intelligence such that I could actually create a book which will know what you've read and actually create something that is bespoke for you, written by me and curated by an artificial intelligence. I think that's a really exciting possibility, but how soon will it be before it puts me out of the job?
So one of the things we touched on the last time we chatted, we were talking about jazz as a parallel in NLP and AI in general, in terms of like jazz, musicians have this kind of a foundational piece. They have a structure that they work off of, right? And that is the basis for improvisation and adaptation. So these systems that we're looking at today, they adapt. They adapt to the nuances of the user and the language and the inputs, right? So we're seeing all of this kind of like these threads kind of connect us together around this creative world and the structured world. And that is kind of like we're trying to find a balance, but we have to find a way forward, that's for sure.
I think that's a really nice example, because in a jazz improvisation, what's so exciting is that feeling like you offer something up and then the person that you're playing with responds to that with their own perspective, which might inspire you to do something that you've never even thought of doing before because of the response. And that call and response means that each individually would not be as creative as the whole band together. Now, I think that's really what you're seeing when artists are interacting with artificial intelligence in their creative practice, that they're offering up perhaps their material, their data to learn on. The AI is looking at that and saying, well, yeah, well, what about doing this sort of thing with your data? And the response is interesting. You might say, no, I don't like that, but that's already an interesting provocation. Why don't you like it? What would you prefer? And one of the most interesting examples I saw in the book about the power of AI to take us somewhere new was actually in an example of jazz improvisation, where Bernard Lubat, a jazz pianist in Paris, he trained up an AI on his sound world, just gave him a lot of examples of his recordings, playing live, and then the AI understood the sort of patterns that he enjoyed, the kind of sound world, but then started creating things which Lubat had never even thought of doing. And after doing a jazz improvisation with the AI, he responded by saying, look, I recognize that. Everything the AI is playing is me. I can hear it. But it's doing things I've never ever thought of doing before. And for me, that's the exciting thing. Even within the data that we have at the moment, there's so much untapped potential that the AI may be able to spot and offer back to us in this kind of improvisational way of playing together.
When you take that consideration and you look at the advancements that are here and the advancements to come, what impacts do you foresee in your fields, right? In research and mathematics?
Yes, we're already seeing it. That one of the things this particular AI is very good at is spotting patterns. It can look at a huge amount of data, and it understands if you change this thing changes in response. And so there seems to be some sort of connection between these. And as I said, we've got a real limitation as humans of our embodiment about the amount of data that I can survey with my eyes and my ears and my brain, which an AI can do much better. So we're seeing fantastic examples of AI, for example, DeepMind trained up an AI on protein folding, and protein folding very often that is very associated with degenerative diseases in the brain. The misfolding of proteins. So understanding how proteins fold and, a knowledge of if a protein is made up in this way, what could it do and what things should it not do, which it might do. The AI has been able to understand that, and AlphaFold, which is the name of the AI, has made just huge progress in this area, way beyond anything that humans are able to do. And I really think that this scientific kind of progress that it's made will be worthy of a Nobel Prize. It'll be very difficult, and this is an issue which actually comes up a lot, is who do you credit for these discoveries, given that it was the AI? Is the AI going to get a Nobel? Is the team? Is the data that it was trained on? All of these issues, I think, actually are issues that come up across the whole board about who should we credit for discoveries made by or creativity of the AI. But I think in my own subject of mathematics, it's very interesting to see the role that AI is already playing. Again, we've seen an example in collaboration with some of my colleagues in Oxford and the researchers at DeepMind in London. They took some data from a mathematical area called knot theory, and the AI threw up a new pattern that we hadn't seen before. But the interesting thing is that the AI is not able to explain why the pattern is there. It doesn't have a very high skills of sort of analytic reasoning, interestingly, because most of this machine learning is done on a statistical level. So it's weirdly not very good at mathematical thinking, strangely. So although it had spotted the pattern, it didn't understand why it was there. And it was up to the humans who were more adept at the analytical reasoning and seeing, oh yeah, I see why there is that pattern, because this thing is related to that, which when you change this will always cause the other thing to change. So, and I think that's quite interesting, because if you ask ChatGPT a mathematical question, most of the time it doesn't get it right. For example, if you say it takes one person 1 hour to dig one field, how many hours does it take two people to dig two fields? Well, the AI says, okay, it looks like everything's gone from 1 to 2, so it goes 2 hours. But actually the answer is 1 hour, because each person is digging the field, takes each of them 1 hour. So it doesn't understand the problem. It does it on a statistical level. And that's kind of one of the limitations, that everything is done statistically, which also means it's done locally, which means it doesn't often have a sense of global structure. So anything that could be teased out from, which is, for example, in the jazz improvisation, it's very good at responding to what it's just heard in the last 30 seconds. But what it won't be very good at is producing a coherent narrative over a half-hour piece. And the AI actually gets boring, whilst the human still feels like they've got something to say. And the AI, I think, is suffering from the fact that it's only locally responding to making something which is consistent with what it's just heard, and isn't thinking about the big picture, which is what we humans are actually quite good at.
You were saying you don't know we don't know who to credit when the AI and the discovery. I think it's probably time for a new prize or new categories around AI and awarding prizes, just because there's going to be so many more discoveries, and we want to credit the teams, we want to credit the researchers around it, but everything that we have today just doesn't cover the framework that is going to be kind of that much more prevalent tomorrow.
I think that's right. Actually, I think one of the things is we need to perhaps get away from this idea of the lonely genius who comes up with all of these things. And I rather like Brian Eno's idea of something that he calls senius, that he said, even before AI came on the scene, every creative act was never just the product of one mind. It was always informed by all the people that person had read, listened to, watched. And so maybe the AI will prompt us into actually crediting collectively other human works of art, which at the moment perhaps are just credited to one person and really should be credited to many people. I think the film industry, for example, has sort of tackled this by saying, look, no one person is responsible for making a film. There are so many people involved. And so they've sort of solved that by creating a corporate identity, which is the owner of the film in some ways, rather than, and each person is recognized as perhaps being more or less important, the director, the stars. I just went with my girls to Harry Potter World, which is all about the making of those films. And they very beautifully end the whole tour that you do with 4,000 boxes looking like boxes containing wands for magic. But each of those boxes has a name of somebody who was involved in the making of those films. And they all are equal boxes. And, from the runner right through to Daniel Radcliffe playing Harry Potter, that there's a recognition within that tour that everybody needs to be credited as part of this creative process. So I think that's what we'll have to recognize with AI, because AI is already challenging. You've got the data that the AI has learned on, and we're already seeing some interesting legal cases coming up in America and beyond about, oh, but you read my book, so I want some money for that. Which I think is slightly crazy personally, because I think, as an author, I read many people's books, and you might be able to sniff some sense of a book that I've read through things that I write. But there's no expectation that I should, use some of my royalties to pay all the people that I read their books. I mean, clearly, if I copy a passage, then I'm going to get done for plagiarism. But I think that this expectation that ChatGPT isn't allowed to read anything is sort of going against actually the way that humans are informed by their reading in order to make the next step. So it's a really interesting questions, which I think are there already even before the AI. And I think the AI is just actually forcing us to think about how do we credit a collective act of creativity. So
you do not believe that if the AIs are trained on works from all over the world, and it's influencing its knowledge set, that there should be royalties or compensation paid out to different writers or creators of the sort?
That is, I really believe that. I think it's just misunderstanding the whole process to believe that you need to be paid for somebody reading your book, whether it's a person or an artificial intelligence. Now, it's certainly a question about plagiarism. If there's ever a passage which is clearly being copied or just slightly rewritten, but we already have laws in place to deal with that. So those can be applied to the AI just as well. And I think I think it's a little bit cheating the way that people teased out that their book must have been used as data, because they asked ChatGPT to such specific questions about their book, and the answers that came back clearly revealed that the book must have been part of the data set. But that was, that's forcing it to plagiarize in a way by saying, asking it if you were going to read this book, blah, 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 blah. So I think that most of the time ChatGPT does a very good job of not plagiarizing, but genuinely synthesizing and producing a new take on the material that it's encountered.
AI is helping us to open up a whole new set of dialogue across so many different areas, and it's reshaping a lot for us. One of the areas that it's going to reshape will be education, right? So what is your vision in terms of what education can and should look like now that we have the most powerful teacher that anyone has ever seen?
I think this is about collaboration and not of replacing the teachers. Again, teachers are very good at spotting the emotional barriers, for example, to learning, which an AI probably would not be so good at. And I've already sort of been experimenting with this, actually. I worked with some colleagues creating something we call mangahigh.com, and it's an internet math school which uses casual gaming in order to try and teach maths up to about the age of 16, 17. And the mechanics of this thing was such that if a student is working well, we push the level up, and basically the machine can tell, okay, well, this person is just eating up these levels of the game. We can push them onto a higher level of interaction with the mathematics. But if it was recognizing that somebody's just struggling and just not getting through levels, it could take the level down, or it could then alert to the teacher to, this is the person you need to intervene with and address, because they've got stuck on something and they've got a barrier. So I think this is really interesting use of this technology, where when a student is just flying, the technology can really help them to just push them to the limits, whilst it's also very good mechanics in identifying those students which really need some personal one-to-one. And so the teacher isn't faced with having to teach 30 students all in one go. As a collaboration with the AI, it can allow the machine to teach those that are responding well to the interaction with an artificial intelligence tutor, and then to spend their time with the people that need the help. So I think this is really going to be a powerful tool. Maybe that mathematics is particularly well suited to this kind of environment, because often answers have correct and incorrect answers. So it's very clear for an AI to be able to judge, yeah, this person has got the answer right and this person hasn't. And so when it comes to something more like a humanities subject, that'll be a little bit more interesting about how powerful the tool will be in, for example, reading essays and assessing whether they've got all the points of the particular Shakespeare that they're reading. I would suspect that it would be quite good at that. So again, the AI in combination with the teacher, I think, will be a very powerful to be able to say, okay, look, this person's really just not understood Macbeth, just doesn't get the themes that are involved. These keywords are just not coming up. You're going to need to spend time with this person. So I suppose on the other side, it's how are we going to cope with students using these new tools? Because, we're all talking about, students getting their essays written by a large language model, and that I think is a danger. But I think rather than sticking our head in the sands and trying to ban the use of these tools, we really need to train our students to use them effectively. So maybe it's about saying, yeah, well, sure, ask the large language model for some ideas, but then make it personally yours by reframing those ideas or challenge those ideas. Don't just accept what it's giving you, we already know that there's a lot of hallucinating going on in large language models. And so you need to be very sensitive to what these things can and can't do. So I think maybe we've been facing this for years anyway in mathematics about the use of a calculator. My personal take is, yeah, they need to learn how to use a calculator, but they also need to have a sensitivity to number to be able to assess when the calculator's perhaps done something wrong, where perhaps you've entered too many zeros and the result just doesn't feel right. Unless you've got a kind of number sense that you've generated outside of the calculator, you won't spot that mistake. And if you're a nurse, that might kill somebody, an extra zero on the end of a amount of medicine that you're about to give somebody. So I think it's giving people the combined skills of, yeah, use these tools, but know how to use things without them as well, to do things without them, because then you'll know when something a bit weird is coming out of this large language model that you need to question, because that doesn't sound like a true source for this idea. I think you've made up that particular reference.
But I also think that some of the problems and some of the challenges that we'll be staring at the next, I won't call timelines on this, but in the years to come, will be so much more complex and so much more involved that we've moved past the calculator. We're going to be moving into a much more complex environment when you start to look at, curing certain diseases, and you start to look at interstellar travel, right? So we're going to be at that point where we need...
Yeah, perfect. Yeah, you're looking nicely into the future there. I suppose one of my roles, I'm a professor of mathematics in Oxford, but I'm also the professor for the public understanding of science. And that role is meant to be helping people navigate all of these new scientific advances such that they can feel that they're in control and they feel empowered, that they're not disenfranchised by not knowing. And so, when I wrote a book like The Creativity Code, one of my missions was not just to show people the impact of this new technology, but actually to try and give people a feel for how this technology works, because that's going to give you the power to perhaps make the thing do something new, or understand the limitations of the technology. So I really tried to get people to look underneath the bonnet, as we call it in England. I can't remember what you call it in America. The hood, yeah. Lift up the hood and look at how the machine. How is this motor working? How is this car actually moving? So I think that's one of we need in education going forward to give our students a level of digital literacy and mathematical literacy and coding literacy that enables them to not be pushed and pulled around by this technology, that they will understand how it's working, what it's doing, how I can hack it to make it do what I want it to do. So I think that will be an important new strand in education, which is part of my role as professor for the public understanding of science, is to try and, help the public as we move into these kind of new... it's across the board. It's not just AI, as you said. It's stem cell research. Well, what is a stem cell? Do I need to worry about that from a moral point of view? I need to understand what it is before I even start to have a moral stance on stem cell research. So, I think that we're in a very fast-moving, we're in a scientific age where science is having such a massive impact. And I sometimes call my role, it's like being an ambassador for this superpower, which is called science. It's like a country where we scientists sit here and we know how it's going on. Even across the scientific world, of course, we need translators. I don't fully understand what somebody in virology is doing compared to mathematics. So, it's infinitely harder for people outside of science to really keep a pace of what's going on. And so that's why you need ambassadors to be able to go and help people understand what is happening to them.
Do you think we're doing a good job at bringing the technology to people and bringing the understanding along with it?
I think we're not doing a good enough job, because I think you're seeing a lot of scare stories about science that if they understood the actual science, these would disappear. So I think we're doing okay. And I think there has been a recognition in the last couple of decades that this is an important role that the scientist needs to engage with. And, my professorship was started in the mid-90s by Charles Simonyi at Microsoft, who realized, no, this is really going to be important that we have scientists going out and not just spending all of their time in the lab. And more you're seeing this being part of the scientific profession, that they need to spend time engaging with the public. But I still think we've got a long way to go. If you look at stories in the newspapers, very often, once a scientific story becomes political, it gets moved from the science correspondent to the political correspondent, and the political correspondent very often doesn't have the scientific literacy to really be able to, and so you get a lot of scare headlines. And I often wonder, are journalists doing this deliberately to sell newspapers? Probably. Or are they just ignorant? Things like 50% increase in the possibility of prostate cancer if you eat bacon. Well, there's no way you can understand what that means unless you understand what are the chances if I don't eat bacon. And if it's like 2 out of 1,000, and a 50% increase means it's 3 out of 1,000, well, that's minute. And I love bacon, so I'm going to still keep on eating bacon because that's not scary. But when you hear 50% increase, you think, oh my gosh, I'm guaranteed to get cancer if I eat bacon. So I think, it's about a responsibility of the media in conjunction with scientists to be able to really deliver the message in the most genuinely truthful way.
How do you believe we can ensure that AI systems remain aligned with human values and ethics as they become more advanced?
Yeah, I think this is a problem that the whole of society has to be involved in. And I think we're already seeing that move, that, of course, the first advances were made by the tech companies, and the tech companies are mostly interested in making flashy new stuff and seeing what the potential of this is, and it's all very exciting. They're also interested in making money, so that's a motivation for them. And so all the decisions were being made up to, pretty recently by one particular section of society. And I think what we're seeing is, no, the government is saying this is a societal issue and we need everybody involved. We need lawyers involved. We need general members of the public involved, politicians, in deciding how we use this new technology. And I think it's interesting that Europe very often isn't as free to do things as, say, China or America, the Wild West and the Wild East. Both of those are really just, saying, let's just try anything. Let's just gather huge amounts of data in China. Let's let the tech boys and girls decide how to use this stuff. Europe is very good at legislation. We already saw that with the GDPR, how people use their data and the protection of data. And we're already seeing new legislation appearing within the European community about how AI should be used. And one of the things, for example, if AI is used in making a decision, for example, in accepting or rejecting a mortgage offer, or in job applications, or in sentencing criminals, that there should be a human there to explain why the decision was made. Now, the intriguing thing is this is almost always impossible, because the AI is such a complex amount of code that, and has trained on such a huge amount of data, that teasing out why it rejected this person and accepted this person for a mortgage, the human will have a huge difficulty in unpicking the reason why, and the AI itself will not have an ability to analyze itself. And so maybe in this case, if you're unable to explain why, maybe that should therefore not be allowed as a decision. And that's what legislation will sort of say. You can only allow AI to be involved if you can explain actually the process about how it came to the decision about rejecting and accepting one person as opposed to another. But that will be a big challenge, because the AI is so complex that that's one of the big challenges and one of the exciting things, of course, because it means that, bizarre new things are appearing out of this learning process that we haven't put in there. And that can lead to really interesting new creativity, but it can also lead to things. It's produced a decision. For example, what about when you come to medicine? That's one of the big places that AI is engaging with, is huge amounts of medical data. And it suddenly says, okay, for your heart condition, I think that you should actually take this drug. And you go, but that drug has nothing to do with heart surgery at all. Why are you recommending? It says, no, that's just, I've looked at all of the parameters and everything like that, and I've seen there's a real amazing correlation between, and you go, but I don't understand why. Yeah, no, neither do I. But honestly, I trust. And so at that point, you say, okay, let's try this. Most of the time, you've got to be cautious because, you've got lives at stake. So I think we're going to have a lot of examples of this where the AI is making suggestions, and unless we can really tease out how it got to that conclusion, we sort of still need a human in the loop. And I think that's, in answer to your question, that's how we try and keep AI on board, is constantly having a sort of feedback loop between the human and the AI, that whenever the AI makes a step, it's got to be somehow integrated with how the human understands it. And that may limit what the AI can do, but maybe that's one of the sacrifices we have to make in order to be able to have a technology that we can use ethically within the way society works.
When you were writing creativity code, what was the one thing that you really wanted to get across to people that are trying to understand that we are moving into a different era with technology and our relationship with technology?
I think one of the things that was really important to me is to get over that this genuinely can push us into the new. That I think most people were feeling and seeing examples of replication of style. Oh, I can have my portrait done in the style of Van Gogh. That's very nice. But I think most people didn't realize that this has got the potential to really come up with something genuinely creative. And that's why I started with the story of AlphaGo, this piece of code that learned to play this very complex game called Go, which is played on a 19 by 19 board. You place black and white stones down. In some ways, it looks very simple because you just try and surround more territory than your opponent, and it's just black and white pixels basically. But the complexity of the game is such that in the past, nobody would be able to write code in a top-down manner to play this game at any high level at all. Chess had been basically cracked in the mid-90s with a computer beating Garry Kasparov, but Go was nowhere near that. So to see the machine learning, a code that learnt how to play and learnt strategy through its interaction with games that it saw that we played and synthetic games that it made itself, to make a powerful player of the game was truly exciting. But for me, the exciting thing was not so much that, because at some point, yeah, sure, a machine's going to be able to beat a human at Go. It was the fact that in the second game of the match that AlphaGo played against the best we humans have, a player called Lee Sedol, it was a match over 5 games. The second game, it made a move that traditionally is very bad that early on in the game, and we now call it move 37 in game 2. It made this move. All the commentators said, oh, what a terrible move. Lee Sedol should win the game by now, from this point. But ultimately, that move was the one that won AlphaGo the game very late on in the game. And so this, I regard as actually the first moment of computer creativity, of AI creativity, because here was a move that it wasn't just things that we'd done before. It was a really new sort of move. And that move has changed the way that humans play this game now. There have been 3 revolutions in the game of Go. One in the 16th century, one at the beginning of the 20th century when a new style of playing emerged. And now AlphaGo has caused this third new way of playing, which is superior to all the ways that we've seen before. And I often use this kind of image of a mountain range, and we humans think we've got to the top of a mountain. We look around and we don't see anything higher than us, and there's sort of fog in the valley, and we say, well, we've reached the highest peak. We've reached the Everest of gameplay. But what AlphaGo did was to go down the valley and go up a mountain that we couldn't see from where we were. And AlphaGo reached a position which was higher than where we were. So what we call this a local maximum in mathematics. We think we're at the peak, but actually there's a higher maximum, a higher peak. So it's only locally the highest point. But and this is the potential, I think, of this. And what I wanted to get across is that it's not just in this game of Go that this could be a game changer, literally in the game of Go, but in many other modes of creativity and productivity and innovation, that it can take data and learn how to do something new. And that's, in particular, a jazz musician gets shown how to play in a new way because of interacting with the AI.
What's your next book? What are you working on now?
I've just submitted my first draft of a new book. It's called Blueprints. And the idea is that mathematics, for me, one of the ways I describe it, it's the study of structure. It's not about numbers and geometry. It's actually the kind of interrelationship between these things. And what I've seen in my work over the years, I've worked a lot, not just within the scientific community, but a lot with creative artists, is that musicians, painters, writers, choreographers, very often structure is incredibly important to their creative process. Take a composer, for example. Understanding an overall structure in a piece allows them to do kind of interesting new things. And when I look at those structures that the artists are using, I very often recognize them from a mathematical perspective, that quite often they've reinvented a mathematical structure through their creative practice, or perhaps they've understood something by reading about some mathematics and implemented it in their creative work. So the book is sort of taking what I call the blueprints, which are the mathematical structures, starting with simple things like the idea of just a circle, or prime numbers, or Fibonacci numbers, but going all the way through to things like the idea of randomness as a structure, or fractals as a structure, and just showing how creative artists are using these structures in their own work, sometimes intuitively, sometimes knowingly. And I suppose the other part of the structure of the book, there's mathematical structures, artistic structures, but the third piece of the shape, the triangle, is natural structures, that very often we see all of these structures, first of all, in nature, and that mathematics is the language to understand nature, and creative artists are very often responding to the natural world. So the book is sort of looking at this triangle of ideas of mathematics, creative art, and nature, and seeing that the structures, these blueprints, are hiding behind all of them.
Oh, that's fantastic. When is this book coming out?
It should come out spring of 2025. So, do look out for that one. I'm very proud of it. It grew out of a lot of work I've done over the decades with creative artists. So it's tapping into a lot of stories that I've gathered over the years. So it's been a nice book to write.
As we come to the end of this interview, the last few questions I want to ask you, right? Overall, are you more optimistic or concerned about the long-term implications of super intelligent AI for humanity, and why? Like, where do you stand on all of it?
I am an optimist. I'm quite a tech optimist, and I think that there's way more potential for good. And clearly, with any new technology, there's always good and bad. And it's about, I think we are becoming very aware of the dangers of this technology, which means that we will be able to mitigate those dangers just in the same way as we have done with other technologies, sometimes not so successfully maybe, but my feeling is that this is got great potential to reveal, to give us a real step change in the way that we do things. So I think that we're aware of the dangers, which is good. There will be unintentional consequences, and we need to be very sensitive to new things as they appear. But I suppose my message, most people I think are very, there's so much dystopia, and it really upsets me a little bit that we aren't seeing the positive side of this technology as much as we are kind of fear-mongering about the negative.
Thank you so much for your time on this. It's fantastic after this conversation. and looking forward to having another conversation when the blueprint comes out next year.
Absolutely. I'll be happy to share my stories with you then.
All right, looking forward to it.